Let's evaluate the continuous time integral of y of t equals to u of t plus 2 minus u of t minus 1, that is linearly convolved with u of minus 2 plus minus t plus 2. Let us find its output y of t. Here let us take that let x of t equals to u of t plus 2 minus u of t minus 1. Let us draw the input signal x of t here. U of t plus 2 is u of t value is 1 when t is greater than or equal to 0. U of t plus 2 is signal shifted to the left hand side by 2 units, starts from minus 2, ends at plus infinity. This value is 1. This is the u of t plus 2. Now let us draw the u of t minus 1. U of t minus 1 is shifted to the right hand side by 1 unit, that is u of t is equal to 1 when t is greater than or equal to 0. U of t minus 1 is, it starts at 1. This value is, this is the u of t minus 1. When this signal is subtracted from this signal, we'll get the input signal u of t plus 2 minus of u of t minus 1. That signal is, that is minus 2 to plus 1. This is the input signal x of t. See here, this is a finite duration signal which its range is only from minus 2 to plus 1. To have a non-zero value output, u of this second signal should come in the range of first signal. Now when you see the second signal, that is h of t, that is h of t is equal to, I'll take u of minus t plus 2. This signal is, first let us take the u of t plus 2. U of t plus 2 is, it is from minus 2 to plus infinity. This is the u of t plus 2. Then you take its reflection, because of the minus sign the signal comes plus 2 to minus infinity. This is the impulse response or h of t. We can take second signal, that is u of minus t plus 2. Okay. Now first signal is a finite duration signal that exists only from minus 2 to plus 1. Second signal, that is u of minus t plus 2, is infinite duration signal that exists from 2 to minus infinity. Now apply the convolution integral formula. Convolution integral formula is, that is the integral of minus infinity to plus infinity x of tau into h of t minus tau into d tau. That is integral of minus infinity to plus infinity. X of tau value is, it exists only from minus 2 to plus 1. Its value is 1. U, that is h of t minus tau, is, that is u of minus of t minus tau plus 2 into d tau. Now let us, we should think about the second signal here. The second signal is u of minus t plus tau plus 2. Okay. Now to get the integration limits here, we should take the second signal for different values of small t. That second signal should come in the range of minus 2 to plus 1 to have a non-zero value. That is, I'll take the case number 1 here. When t is equal to 0, what happens to second signal? When t is equal to 0 here, it becomes u of tau plus 2. U of tau plus 2 means what? This signal comes from minus 2 to plus infinity. This is the u of tau plus 2, minus 2 to plus infinity. When this signal multiplies the first signal, the multiplication is possible. complete x of t signal is multiplied with the second signal, that output is not equal to 0. Multiplication is possible from -2 to +1. That is multiplication of both the signals, multiplication of both signals is possible from -2 to +1. Similarly, let us take the second condition, that is case number 2, when t is less than 0. Suppose if I take t is equal to -1, what happens to that is u of, we have minus t plus tau plus 2. This is the second signal. When t is -1, this becomes u of minus will become +1. There's 1 plus tau plus 2. This is nothing but u of tau plus 3. That is, when you draw that signal, the signal comes in the range of, that is, -3 to +∞. Okay, this is the u of tau plus 3. Here also the multiplication is possible with the first signal. Hence y of t is not equal to 0, but first signal range is only from -2 to +1. That is, output exists, lower limit is -2, upper limit is +1. Similarly, I can take t is -2. If I take t is equal to -2, you'll get u of minus will be +2 plus 2. It will become u of tau plus 4. It exists from -4 to +∞. This is t. This is u of tau plus 4. Then also multiplication is possible, but first signal range is only from -2 to +1. Complete signal is multiplies with the first signal. And the multiplication range is -2 to +1 when t is less than or equal to 0. Now let us take case number 3, when t is greater than 0. I'll take t is equal to 1. When t is equal to no, that is u of -1 plus tau plus 2. This will become u of tau plus 1. This exists from -1 to +∞. Then the multiplication, then also answer is not equal to 0. Multiplication is possible from -1 to +1. Y of t is not equal to 0 for the range -1. Multiplication is possible from -1 to +1. Suppose if we take t is equal to 2, then it becomes, it is u of -2 plus tau plus 2. It will become u of tau. The signal exists from 0 to infinity. Then also output is not equal to 0. Output is not equal to 0, but multiplication is possible from 0 to 1, because first signal exists in the range of -2 to +1. Suppose if I take t is equal to 3, you'll get second signal is u of -3 plus tau plus 2. It will become, that is, u of tau minus 1. Then second signal exists in the range of 1 to infinity. This is u of tau minus 1. Hence here also output is not equal to 0, because at 1 the multiplication is possible. Multiplication is possible only at t is equal to 1. When t is greater than 3, signal exists after 1. After 1 the first signal does not exist, hence the output is equal to 0. That means I can conclude that here, that is, output exists y of t is, from these three cases you can conclude that y of t is not equal to 0 when t is less than or equal to 0, and t is not equal to 0 up to when t is in between 1 to 3, and output is equal to 0 when t is greater than 3. Now let us see from this here, when t is less than 0, output is not equal to 0, complete signal is multiplies. When t is greater than or equal to 0, that is when t is greater than 0, based on value of t it multiplies. That is when t is equal to 1, lower limit is -1, upper limit is +1. When t is equal to 2, lower limit is 0, upper limit is 1. When t is equal to 3, lower limit is 1, upper limit is also 1 here. That means I can decide here, that is y of t is equal to, know that, integral of -infinity to plus infinity x of tau into h of t minus tau into d tau. Both are ones here because both are unit step function. I'll take the conditions here. When t is less than 0, when t is less than 0, complete signal is multiplied. You'll get y of t equals to integration of -2, that is lower limit is -2, upper limit is 1. For any value which is less than 0, complete signal is multiplied. This is also 1 and this is also 1, that is d tau. Answer is tau. Substitute the lower and upper limits, you'll get answer is 3 when t is less than 0. When t is in between greater than 0 and less than 3, that is when t is in between 3, that is y of t is equal to, upper limit is 1, lower limit is t minus 2, because when t is 1, it starts from -1. When t is 2, it starts from 0. When t is 3, it starts from 1, ends at 1. It is y of t equals to tau. Substitute the lower and upper limits, you'll get 1 minus of t minus 2. Answer is 1 minus t plus 2. You get answer is 3 minus t. And so you have three answers here. That is y of t equals to, first answer is 3 when t is less than 0. Next is 3 minus t when t is in between equal to 3 and 0 when t is greater than 3. Now let us draw its output signal. When t is less than 0, this is t, this is the output signal y of t. When t is less than 0, output is, that is 3, so it is fixed. This value is 3. Up to 0 to 3 you have answer here. As t increases, when t is 1 it will become 2, when t is 2 it will become 3 minus 2 is 1, when t is 3 it will become 0. Slowly decreases and it becomes 0 at t is equal to 3. This is the output signal. Thank you.